I've always wanted to make a robot arm, but I haven't looked into it until recently. I got obsessed with robot arms because of their functions and complex design, but I've heard it's hard to make one. So today we'll find out if I can make one. I thought of making a 6-axis robot arm controlled by an Arduino-powered. I will take you through the process of making the robot arm, and you can follow along using the project files in the description. So let's get started. As a robotics enthusiast myself, first I researched about robot arms, and then I decided on designing my own robot arm because some commercially available robot arms were too big, too small, or too flimsy to put on the Asika version 2 project, which will be in an upcoming video. At first, I didn't know what to do because I had no experience designing a robot arm before. So I created an exact replica of the servo motor and started designing everything else around it. And it took about 8 hours of designing and 6 hours of 3D printing. I made my design a physical object with the help of 3D printing technology. I used PLA plus material for the 3D prints. I bought 6 MG995 servo motors, a grabber, some M3 nuts and bolts, 3 ball bearings of 8mm inner diameter and 22mm outer diameter, jumper wires, an Arduino Mega, and a 16-channel I2C servo driver from my local electronics shop to make the robot arm. It took way less time to make because I used nuts and bolts in the robot arm to make it more durable. I fixed everything together in about 15 minutes, starting from the base of the robot and building up. Some clearances were tight because I forgot to level the 3D printer bed. I added some ball bearings to make the base motor turn with minimum friction. So this is where things started going wrong. I don't know how I missed this one in the designing process, but this important servo motor was only held by a little piece of plastic. So obviously it failed. And there were some other minor design issues as well, so I had to redesign and reprint multiple times. It was really hard to schedule a time to 3D print during daily power cuts. The whole assembly was off-center, so it had a really hard time balancing during movements. There was about 2 centimeters of play at the gripper, so obviously I had to fix that. The play mostly came from flexible plastic and the cheap servo motors. So after fixing those issues, let's continue the project. Now it's the time to wire everything together. I created this wiring diagram to help me do the wiring. First, I wired all the ground connections and all the positive connections. Then I connected all the data wires and protect them from any interference. I connected all the servos to the servo driver and connected the power supply. It was time to start coding. I'm not gonna explain the code I wrote in detail, but if you are interested, there's a link to the code in the description of the video. So this is the code of the robot arm. First we include the PWM servo library, then we define the I2C address, then we set the servo frequency, and then we set the arm to begin and set the oscillator frequency and set the PWM frequency to servo frequency which we defined earlier. And in the void loop, this first value here is the motor 1, this is the motor 2, motor 3 in the servo driver, and the servo motor rotates according to this value. As you can see, I have added some for loops as well to make the motion smoother, and you can fully customize this robot arm. At first, the robot arm didn't move. Then I found that one servo motor was not working. After replacing that, I uploaded the final code and it worked. The robot arm works better than I hoped it would. And now I can program it to do anything I want, like grabbing an object and placing it on top of a box. Make the robot arm dance. And make it lift a stick. You can also improve the design or the code of the robot arm. So guys, I hope you enjoyed this project and I will be using this robot arm on my Asika version 2 to clear clutter or grab objects. And if you were to build this, it would cost around 16,200 rupees or $44. So if you enjoyed this video, consider subscribing. It will be a big help for me. Merry Christmas, Happy New Year, and stay tuned. See you next time. Bye.